Hi, in this video, we'll be looking at circles. Now, a circle is a set of points equidistant to a fixed point called the center. So in the diagram that you can see below, we have here, circle O. So we will call this circle a circle O. The name of the circle is actually the center. So we have here the center as O. The segment OA is the radius. Segment BC is the diameter and segment ED is a chord. Note that the diameter is also a chord, but it is the longest chord in the circle because it passes through the center. Now, what are the different arcs in a circle? So again, let's look at circle O. Angle AOB, so angle A, O, and B, this one, is the central angle. This is called the central angle because it's an angle made with the center as the vertex. Angle AOB intercepts this arc AB. So this is arc AB and it is intercepted by angle AOB. We call this angle AB or arc AB, as a minor arc. Also, we have arc A, C, and B. And this is called the major arc. Arc CAB and arc CDB are semicircles. Okay. Now, basically, the measure of an arc is numerically equal to the measure of the central arc that intercepts it. So, if the measure of, for example, if the measure of um, angle AOB, let's just put it here. Okay, so if the measure of angle AOB is equal to 75 degrees, then the measure of arc AB is also 75 degrees. Also, the measure of a semicircle is 180 degrees. We know that the measure of the whole circle or the circumference of the circle is 180 and semicircle is 360 and the semicircle is uh, half the whole circle. That's why 360 divided by 2, the measure of a semicircle is 180 degrees. Let us now look at the central angles and their corresponding arcs. Remember the following. If the measure of two central angles are equal, then their corresponding chords have equal measure. So supposing I have here circle B, and then we will form a central angle. For example, central angle, we will name this as central angle. This one is A and this one is C. And then I will make another central angle here and I will name it D and E, the points D and E. And then the chords connecting the points so wait, I have your A. So if I draw a chord connecting the 2 points here, AC and DE, if for example, the measurement of angle ABC is equal to, let's say, 60 degrees, and the measurement of angle DBE is also 60 degrees, then we can say that the measure of AC is equal to the measurement of DE. So since both of them are 60 degrees, hence AC and DE are equal. Another is, if the radius is perpendicular to a chord, then it bisects the chord. So again, if the radius is perpendicular to a chord, then it bisects the chord. That means it splits the chord into two. Also, if the radius intersects a chord other than the diameter at its midpoint, the radius is perpendicular to the chord. So let's have an example. So supposing we have, again, circle, let's have circle B, and then let us form a chord. This chord is A and C. So if, for example, the radius, let's say BD, the radius BD is perpendicular to AC, then it means that BD bisects the chord. On the other hand, if, for example, um, we have here the chord E and F, and we have G, which is the midpoint of F and E, or segment F, your chord FE. And if it intersects, if the radius intersects the chord at its midpoint, then it is perpendicular to the chord. So again, if you put that into words, if segment FE is a chord of circle B and F is its midpoint, and if G is its midpoint, then radius, let's have a radius BH. Then radius BH is perpendicular to chord FE if it intersects at point G. But if it does not intersect at the midpoint of a chord, then it's not perpendicular to the chord. The radius is not perpendicular to the chord. Another is, the perpendicular bisector of a chord of a circle contains the center of the circle. Also, the intersection of the radius drawn perpendicular to a chord is the midpoint of the chord. So it's very similar to what was given before, or in the previous concept or definition. But remember, perpendicular bisector of a chord will always contain the center of the circle. And the intersection of the radius drawn perpendicular to a chord is the midpoint of the chord. Now let's go to inscribed angles and intercepted arcs. Here on the right, you can see a circle O, and then you can see here an angle made by points A, B, and C. So here, please note that the inscribed angle is angle ACB. So this is the inscribed angle. While arc AB, is the intercepted arc. And based on our definition, or based on our concept, the measure of the inscribed angle is half the measure of the intercepted arc. This means the measure of angle C is equal to one half the measure of arc AB. So if arc AB is 75 degrees, then angle C is one half times 75, which is 37.5 degrees. Also, an angle inscribed in a semicircle is a right angle. Looking at this illustration, we have here circle O, and we have the angle A, B, and C. As you can see, angle ABC is the inscribed angle, and the measurement of any inscribed angle of a semicircle is 180 degrees. So as you can see, arc ABC is a semicircle. Therefore, angle ABC is equal to 90 degrees, following the rule that it is one half of its intercepted arc. So let's now take a look at the following problems. Given circle O and measurement of angle AOB is equal to 100, and this figure, let us find measurement of angle 1, the measure of angle 2, the measure of angle 3, and the measure of angle 4. So looking at the illustration, angle 1 here is an inscribed angle, and its intercepted arc is arc AB. So let me just highlight that. This is the intercepted arc, which is arc AB. And we know that based on our definition a while ago, the measurement of the inscribed angle is one half the measure of its intercepted arc. So this means angle 1 is one half the measure of arc AB. And from there, we can say that it's one half times the measure of 100 degrees, which is 50 degrees. For angle 2, again, if you look at angle 2, it is an inscribed angle, and or it intercepts the arc AB. Hence, it's also one half of AB, which is 100. So one half of 100 is 50 degrees. This also goes for angle 3 because again, the intercepted arc is AB. So it's also 50 degrees. Let's look at angle 4. Here is angle 4. And the intercepted arc of angle 4 is ACB, or arc ACB. And that is actually an arc that is the major arc because AB is our minor arc. It is intercepted by the central angle. So this means that in order for us to get that, this is already 100. AB is already 100. That means to get the major arc, it should be 360 minus 100. And that would give us 260. Hence, measurement of angle 4 is one half of 260 degrees, which is equal to 130 degrees. Next, given AC is a diameter and the arc AB is 130 degrees, let us find measurement of angle 1, measurement of angle 2, and the measurement of angle 3. But before that, let us draw first the figure. So let's have the circle. I will be drawing the circle here. So we also have the following points. We have here point A, point B, point C. This is angle, oops, point C. This is angle 3. This is angle 2 and angle 1. Okay. So AC is the diameter of the circle. This means that arc ABC is a semicircle. And that means that angle 3 is an inscribed angle. Angle ABC or angle 3 is the inscribed angle, which means that it is actually 90 degrees. No, based on our discussion. The inscribed angle of a semicircle is 90 degrees. So we will have here that measurement of angle 3 is 90 degrees because angle 3 is inscribed in a semicircle. Okay, so let's continue. Now, supposing I will put here that so we have there angle 1, and we said there that angle 1, if you look at angle 1 is actually intercepted, has an intercepted arc of AB. So this is angle 1, and this is its intercepted arc. And we said that the inscribed angle is one half of its intercepted arc. Therefore, it would be one half AB, which is equal to one half of 130, and that is 65 degrees. Similarly, if you would look at angle 2, its intercepted arc is arc BC. And arc BC, if this is 180 degrees and this is 130 degrees, that means um, if you subtract that, that's 180 degrees minus 130 degrees. That means the arc BC is 50 degrees. So this one is 50 degrees. And then angle 2 is inscribed in arc AB. So we will have 1 half arc BC, which is equal to 1 half times 50, which is 25 degrees. Hence, the measurement of angle 1 is 65, angle 2 is 25, and angle 3 is 90 degrees. On the next video, we'll be looking at tangents and secants of a circle and how can these measurements be solved.